All right, so 2.2, we did a derivative activity. What we found was that there are some patterns that we can see from functions to expressions of the derivatives. We found out that there is some kind of multiplication between coefficients and exponents. That helps us to get a coefficient for a term in our derivative. We also found out that constants yield a 0 or nothing, and we have 3x to the power of 1. When that turns into a derivative, the x kind of gets dropped. So those translated into a couple rules. The first one was the constant rule. If you are taking the derivative of any function that is a constant, like f of x equals 5, the derivative always is just 0. Okay? So that's the constant rule, and that's simply because if we had graphically a graph that was y equals a constant value, the slope of the tangent line anywhere on that line would be the same as the line itself, which would have a slope of 0 always. All right, did some practice here. Any constant function has a derivative of 0. We next talked about the power rule. The power rule is this is where we make a formal connection between the coefficient and the exponent. And the basic power rule says that if you have x to the power of any number n, then the derivative of that term will be the exponent itself, n, times x to the power of n minus 1. So the pattern here, if the function is x to the 5, we bring the 5 down and we subtract 1 from the 5 and put that as the new exponent. This is the derivative of x to the 5. It's 5x to the 4th. Same thing, bring your coefficient down, subtract 1 from the exponent, negative 3x to the power of negative 4. Fractions and negatives are all the same. So we brought the exponent down as a coefficient and then subtracted 1 from the original exponent, and that was our new exponent. We did note that if you have a negative coefficient, it's going to be proper to get rid of the negative on the on the exponent. It's going to be proper to get rid of that negative by bringing that down. So in this case too, we could have written this as negative 3 over x to the 4th. So now we are at some problems here. So let's launch into this example number 3 here. I think this might be from your assignment, your homework assignment too. So we'll do 3a. That's part of your homework assignment for today. We'll do that with you. So we got to use our rules to find the slope of the tangent line to the graph of the given function at the point whose x-coordinate is given. So what we've been doing so far is using the rules to find expressions of the slope of the tangent line. And now we're actually asked for values of the slope of the tangent line, which really, when we find the derivative, so we're going to find the derivative, and then we're going to plug the value that's given in for x. So really what we're looking for here is f prime of 1/3. So we're going to find this first, and then we're going to plug the value in and find our answer. So let's give this a try. The power rule says that we take the exponent and we bring it down, and if there's a number that's already in front of this, we multiply. Okay? So this is going to be 3 times 2. That's going to be 6. Keep our variable x to the power of 3 minus 1, which is 2. Got that? We good with that? Okay, that is the derivative of 2x cubed, 6x squared. Right. Okay, so what we do now is we write 6 to the power of 1/3 squared. Remember our order of operations. We're going to square the 1/3 first, so that's going to be 6 to the power of 1/9. 6 over 9. Make sure you reduce every fraction that you come across. That's going to be what? 2/3. So the slope of the tangent line, m equals 2/3. That's your answer for this one. All right. All right.